So our today's topic is called matrices. That is the topic of today. It's called matrices. This is what we are going to discuss today. And when we talk about a matrix or matrices, a matrix is simply a rectangular arrangement of numbers. For example, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that is a square, but by definition, we call it rectangular. So a matrix is a rectangular arrangement of numbers which are enclosed within brackets. So we have brackets. When you are giving the name of a matrix, we always use the capital letter. We always use the capital letter. And when you are using the elements, when you are labeling the elements, we use small letters. Now, this horizontal arrangement of numbers is called a row. It's called row. And rows are represented by letter I. And then this vertical arrangement of numbers is called a column. And columns are represented by small j. The intersection where the intersection of the row and the column where a particular value is, that is the detail that we use to label the position of an element. For example, this one is a number that is in row number 2 and column number 1. This is an element that is in row number 3 in column number 2. So it is 3, 2. This is an element that is in row number 1 in column number 3. So the intersection of the rows and columns, it is used to define the position of the elements. Then, if you look at these items that are here, these ones, they form what we call the major diagonal. We call them the major diagonal. We can also call it the lead diagonal. We can also call it the lead diagonal. These ones that are here, sorry, it is the opposite. The opposite, I've put the opposite. This is what we call the major diagonal. And this is what we call the minor. I'm not confusing that. Yeah, the major diagonal. This is the major, this is the minor. So this is not the lead, this is the major, and this is also called the lead. This one is the major diagonal. This other one is the lead, is the minor diagonal. Then the number of rows and columns that are in a particular matrix, they are known as order of the matrix. The number of rows and columns, they are known as order of the matrix. Like now, this one is a 3 by 3, meaning it has 3 rows and it has 3 columns. And whenever we are giving details about matrices, we always start by showing the details of the rows, followed by the details of the columns. So that is the description of what we call a matrix. Now from there, I want to discuss the types of matrices that you will easily come across. The types of matrices that you will easily come across. Now these types of matrices, there are many, as you can see in your handout. The first matrix that we have is called zero matrix. Now, zero matrix is a matrix that has no element. For example, when we say that is our matrix, that is called zero matrix. It's a matrix that has no element. Then we have what we call the sigotone. The sigotone, some people prefer to call it the scalar matrix. This is a matrix that has only one member. For example, when you give us a 7, that is a sigotone or a scalar matrix. The other one that we have is called square matrix. Now, square matrix is a matrix whose number of rows is equal to the number of columns. The number of rows is equal to the number of columns, like the one that we had just drawn here. The other one that we need to know is called row vector matrix. Row vector matrix. Now, the row vector matrix is a matrix that has only one row and more than one column. For example, 2, 3, 4, 5. Now, this one, it is the matrix which is a 1 by 4. It has one row and 4 columns. That is the row vector matrix. Then we have what we call the column vector matrix. Now, the column vector matrix is a matrix which has only one column and more than one rows, like 2, 3, 4, 5. Now, again, there is a matrix which is a 4 by 1. It has 4 rows and it has one column. The other matrix that you need to know is called identity matrix. It's called identity matrix. And identity matrix is a matrix whose major diagonal elements are 1s and the others are 0s. The identity matrix 1 or I. These are 2 by 2 matrix. The major diagonal elements, they are 1s. Or if it's a 3 by 3, then it will be something like this. If it's the 3 by 3, it will be something like this. You can see the major diagonal, the values are 1s. The values are 1s, and all the others are 0s. So this is a 3 by 3 matrix. It's a 3 by 3 matrix. And the identity matrix, as you can see in your notes, it is used to multiply other values. It is used to multiply other values or other matrices, such that matrix A multiplied by the identity, it is that matrix. And then matrix A, when it's divided by identity, is just that matrix. Just like, for example, if you have 3 times 1, it is 3. If you have 3 divided by 1, it is just 3. So that is what we call the identity matrix. The next one is called transposed matrix. Transposed matrix. Now, a transposed matrix is a matrix whose rows and columns have been interchanged. Is a matrix whose rows and columns have been interchanged. So, if you have 2, 3, 4, 5, yeah, and this is matrix A, and you are told to get A transpose, A raised to power T, what you need to do is this row here to become the first column that way, and this row here to become the second column that way. That's how you transpose. If you have a matrix B here, which is 2, 3, 4, 5, 6, 7, that way, and you are told to transpose there to get B transposed, now we are going to have 2, 3 here, we are going to have 4, 5, we are going to have 6, 7. So that is how you transpose. To transpose means to interchange the rows and columns. Now from there, we have the operations of matrices. The operations of matrices. Now, when we are told to operate matrices, we have some rules that should be followed, as you can see on page 3. Number 1 is you determine the order of the matrices. Involved. Number 2, you establish whether the matrices satisfy the requirement of the operation. Number 3, you determine the order of the matrix that will be obtained after the operation. Number 4, you undertake the operation. And number 5, you interpret the elements, the matrix obtained if need be. So those are the steps that we take anytime we are operating matrices. Anytime we are operating matrices. Now, this is what I would like us to do now, because already you have these notes. Now on your book now it's time to write. I expect you already have written that the topic is matrices. So we are told, or we want now to do the first operation. So you write this. Number 1 is addition and subtraction of matrices. Subtraction of matrices. Addition and subtraction of matrices. If you are told to add or to subtract matrices, and there is example 1 here. Example 1. Example 1. This is what happens. If you are told this is 3, 4, 5, 6, you are told to add 3, 8, 7, 9, 4, 2. If you are told to add those matrices, tumesema the first step is to know the order of the matrices. So this one is a 2 by 2. It's a 2 by 2. And this one is a 3 by 2. Is a 3 by 2. Now, when you come to adding or subtracting matrices, matrices can only be added or subtracted if they are of the same order. Now, these ones, you can see this is not the same as this. So here, you simply tell us it is not possible. Why is it not possible? Because they are not of the same order. It's not possible to add those ones because they are not of the same order. Example number 2. Example number 2. If you are told to add 3, 7, 8, minus 10, minus 6, minus 12, 5, 9, 10, you have a matrix like this one, and you are told to add another one here, which is minus 2, minus 4, minus 3, 12, 8, or let me talk of 18, then minus 4, then this is 6, this is 2, this is minus 3. If you are told to add a matrix like that, the first thing again is to check the order of those matrices. Now you can see this is a 3 by 3, and this one is a 3 by 3. 3 by 3. So they have the same order. So if they have the same order, those matrices can be added. And the next thing that you need to check is to know what will be the order of the answer. Now, the order of the answer, when you are adding matrices, it is the answer that you get will be of the same order as the matrices that are involved. Will be of the same order with the matrices that are involved. So now that this is a 3 by 3, I'm also going to get a 3 by 3 matrix. I'm also going to get a 3 by 3 matrix. And the addition of matrices is very simple. The addition of matrices is very simple. This is what you do. You take this 3 plus this minus 2. So 3 plus minus 2, that gives me 1. I have 7 plus minus 4, that gives me 3. 8 plus minus 3, that gives me 5. I have minus 10 plus 12, that gives me 2. Minus 6 plus 18, that gives me 12. Minus 12 plus minus 4, that gives us minus 16. 5 plus 6, that gives us 11. 9 plus 2, that gives also 11. 10 plus minus 3, that gives us 7. That gives us 7. So that is what you get when you add matrices. That is what you get when you add matrices. Then for your assignments, I would like you to add these matrices: minus 4, minus 3, minus 8, 10, 7, 6, minus 5, 9, minus 2. You add 8, 10, 16, minus 2, 3, 4, 5, 6, 7. I would like you to add that later on your own. So leave a small space that you shall use to do that. After you have done that, let us go to the next operation. Let us go to the next operation, which is called multiplication of matrices. Multiplication of matrices. Multiplication of matrices. Multiplication of matrices. Now, when you are told to multiply matrices, we have example 1 here. Example 1 here. You are told to multiply matrices. To multiply matrices. You are given 2, 4, 5, 6 times 3, 1, 6, 7. We are told to multiply those matrices. We are told to multiply those matrices. Now, the first thing is to check the order of the matrix. The first thing is to check the order of the matrix. Now, this is a 2 by 2, and this is a 2 by 2. The 2 by 2. When you're multiplying matrices, you must confirm that the number of columns here is equal to the number of rows here. The number of columns here is the same as this one. We say they are compatible. If they are compatible, then they are multipliable, and you will get a matrix with 2 rows and 2 columns. So you come here and write the solution. So the solution will be a matrix which is a 2 by 2. Will be a matrix which will be 2 by 2. The solution here will be a matrix which will be a 2 by 2. Assume that matrix is matrix C. So we will have an element in row 1, column 1, an element in row 1, column 2, an element in row 2, column 1, and an element in row 2, column 2. That is how our solution will look like. That is how our solution will look like. Now from there, you start looking for these values. So we start to get C11. Or we come to get C11. Now in coming to get C11, coming to get C11, what this means, you will need to take the values in row 1 and column 1. So utasema 2 times 3, 2 times 3 plus 4 times 1. 4 times 1. Give me the answer and be fast. Give me the answer. That is 2 times 3 plus 4 times 1. Give me the answer.
10.
10, good. So this is equal to 10. You come and get this one, C12. C12. You take the values in row 1 and column 2 now. So that will be 2 times 7 plus 4 times 6. 4 times 6. So give me the answer, 2 times 7 plus 4 times 6.
That's 8.
38, good. We come here and get C21. So C21, it is the values in row 2 and column 1. So we take this one, we say 6 times 3 plus 5 times 1. So 6 times 3 plus 5 times 1.
23.
23, good. We come here and get C22. C22, it is the values in row 2 and column 2. So that will be 6 times 7 plus 5 times 6. 6 times 7 plus
72.
5 times 6, you're getting?
72.
72, good. 72. So that is how you get the answers. And therefore, your matrix will be 10, 38, 23, and 72. That is the matrix that is your answer. That is the matrix that is your answer. Let us have example 2. Example number 2. Example 2. Now in example 2, you have 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6. You are given 2 matrices of that design. 2 matrices of that design. Nimesema what you do first is you multiply, you check the order. So this one is a 3 by 2. 3 by 2. And this one is a 2 by 3. The 2 by 3. Now for you to multiply matrices, the number of columns in the first one should be equal to the number of rows in the second one. So now that these columns are equal to these rows, it is possible to multiply. So what will be the solution looking like? What will be the solution looking like? So according to our guide, we are going to have a matrix that will have 3 rows and 3 columns. So that means we have an element in row 1, column 1, an element in row 1, column 2, an element in row 1, column 3. Then we'll have an element in row 2, column 1, row 2, column 2, row 2, column 3. An element in row 3, column 1, row 3, column 2, row 3, column 3. Those are the items that we are going to have. Those are the items that we are going to have. So if that is what we are going to have, then we begin working for them. We begin looking for those items. So when we come here and say C11, we are taking the values in row 1, column 1. So it is 2 times 1 plus 5 times 2. Get the answer? 2 times 1 plus 5 times 2 is equal to what?
12.
12. Good. Haya, tukuje kwa huyu mwingine C12. It is row 1, column 2. So it is 2 times 3 plus 5 times 4. So this will be 2 times 3 plus 5 times 4.
26.
26. We come here to C13. Now C13, we take the values in row 1, column 3. So that will be 2 times 5 plus 5 times 6. So 2 times 5 plus 5 times 6.
40.
40. Good. Now tukuje kwa hii ingine C21. C21, it is now you take the second row, first column. So 3 times 1 plus 6 times 2. So 3 times 1 plus 6 times 2.
15.
15. Yet. We go for C22. We take the values in row 2, column 2. That is 3 times 3 plus 6 times 4. 6 times 4. So 3 times 3 plus 6 times 4 is 33, yeah?
Yes.
C23. C23 will be now the second row, that column. 3 times 5 plus 6 times 6. So 3 times 5 plus 6 times 6 is
51.
what?
51.
51. Good. Now we go to C31. C31, this one, it is the third row, first column. So 4 times 1 plus 7 times 2. 7 times 2. So 4 times 1 plus 7 times 2 is
18.
what?
18.
Then C32. C32. So row 3, column 2. So that is 4 times 3. 4 times 3 plus 7 times 4. 7 times 4. So 4 times 3 plus 7 times 4 is
40.
what?
40.
40, yeah? It's 40. And the last one, C33. C33, it is the third row, third column, 4 times 5 plus 7 times 6. 7 times 6. So 4 times 5 plus 7 times 6 is
62.
62. So that means our answer is 12, 26, 40, 15, 33, 51, 18, 40, and 62. That is the answer that you get when you multiply those matrices. Okay. For your assignments, 3, 4, 5, 6, 7, 8. You multiply by 1, 2, 3, 4, 5, 6. That is what I would like you to do on your own. After you have copied that, let's now proceed to division of matrices. Division of matrices. Division of matrices. Now, when it comes to division of matrices, we use inverse. We use inverse. We use inverse. You can write something like this. If you are told to get A, you divide by B. It is B inverse multiplied by A. When you write it this way, that means inverse. B raised to power minus 1, that is inverse of B. Inverse. Inverse is the other one for the reciprocal. Reciprocal of B. That is how we go about it. So we do not divide matrices, but we invert them. So we use the procedure called inversion. We use a procedure called inversion. Now, the inversion procedure depends on the order of the matrix. Depends on the order. So if you have a 2 by 2 matrix, katika inverse of a 2 by 2 matrix, or a 2 by 2 matrix, if we are told to get inverse of a 2 by 2 matrix, so the first thing is to get the matrix, is to have the matrix here. So the matrix is 2, 3, 4, 5. You have the matrix there. 2, 3, 4, 5. Now the next thing that you do is to get the determinant. The determinant of the matrix is to get the determinant of this matrix. So the determinant, let me assume this is matrix A. So the determinant of A, the name of the matrix between two strokes. You take the major diagonal elements, that is 2 times 5. You subtract the minor diagonal, that is 4 times 3. So give me the answer. If you say 2 times 5 minus 4 times 3 is equal to what?
Minus 2.
Negative 2. That is the determinant. The next thing you do is to create what we call new matrix. Now, new matrix is created by changing the positions of the major diagonal and changing signs of the minor. So this will be 5 here and 2. Then these ones which are positive, they become negative, minus 4 and minus 3. So you change the positions of the major and you change the signs of the minor. That's what we are calling the new matrix. And once you have done that, the inverse, that is the inverse of A, as you can see in your notes, you get the determinant 1 out of minus 2. You multiply the new matrix. The new matrix is 5 minus 4 minus 3 and 2. You can choose to leave it this way, or you can choose to open the brackets. You can choose to open the brackets. So if you open the brackets, this will be minus 2.5. This will be 1.5. This will be 2, and this will be minus 1. You can choose to leave it, or you can choose to open the brackets. Example number 2. Example number 2, if you have a matrix here, matrix B, which is 7, -8, 9, and 20, if you are given a matrix like that one. So the first thing is to get the determinant. I've said we get the determinant. And the determinant is the determinant of matrix B is you take the major diagonal, that is 7 times 20. You minus the product of the minor diagonal, that is 9 times minus 8. So give me that answer. 7 times 20 minus 9 times minus 8. What is the determinant? The answer?
212.
212, please. 212. So the new matrix, you change these positions so that we have 20 here and we have 7. Then you change the sign. So this becomes minus 9 and this becomes positive 8. That way. So with that, the inverse of that, the inverse is B inverse is 1 out of 212. You multiply by 20, raise negative 9. Then we have 8 and 7. So that one we can leave it that way. We can leave it that way. There's no need of opening. Now for your assignment on that, this one, you can have matrix C, which is 11 minus 4 minus 10 and 16. So get the inverse of that matrix. Get the inverse of that matrix. So that is how to get the inverse of a 2 by 2 matrix. How to get the inverse of a 2 by 2 matrix. Let's now look at how do you get the inverse of a 3 by 3 matrix. 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 So let's take our matrix A here to be 3, 7, 8, 9, 2, 4, 5, 6, and 1. If you have that matrix and they told you to get the inverse, how do we go about it? So again, as you can see in your notes, there are several steps that we are supposed to take. And the first step is called to get the minus matrix. So step 1, we are saying is to get the minus matrix. Minus matrix M. Minus matrix M. And minus matrix M, it is gotten like this. Make sure you are following well. You come and there is a big one. So maybe it will start here all the way to here. So this is matrix M. Text M. Brother, mute yourself. So what we do, you come and stop here at these 3. You delete these elements in the first column and the first row. You unaachiwa 2, 4, 6, 5, and then you put them within 2 strokes that way, because it's a determinant. Unakuja hapa kwa 7, you drop everything in that row and in this column. You unaachwa na 9, 4, 1, 5. Again, you put them inside 2 strokes. When you get here where we have 3, where we have 8, you broke this column and you broke this row so that you're left with 9, 2, 1, 6. That way. Then you come here where we have 9, broke everything where there is that 9, this row and this column. You are left with 7, 8, 7, 8, and 6, 5. 7, 8, and 6, 5. You come here where we have these 2, broke this row and broke this column. You are left with 3, 8, and 1, 5. And you come where we have these 4, you broke this row and you broke this column so that we have 3, 7, and 1, 6. 1, 6. When you come here, you broke this row and this column. So we have 7, 8, and 2, 4. You come where we have this 6, you broke this row and this column so that you have 3, 8, and 9, 4. That way. Then you come to the last one here. You broke the 3rd row and the 3rd column so that you have 3, 7, and you have 9, 2. So that is how it is done. So this proceeds to become, as I told you, when you put anything inside these 2 strokes, it is the determinant. And as we know the determinant, as you know how to get the determinant, it is you get the elements which are there, you multiply and subtract. So to chukua calculator, we start going. So I will say 2 times 5 minus 6 times 4. 6 times 4. I'm getting negative 14. Then ikuja hapa niseme 9 times 5 minus 1 times 4. Getting 41. So be confirming so that if I get it wrong, you'll tell me. 9 times 6 minus 1 times 2 is 52. 7 times 5 minus 6 times 8 is negative 13. 3 times 5 minus 1 times 8, 7. 3 times 6 minus 1 times 7. 7 times 4 minus 2 times 8 is 12. 3 times 4 minus 9 times 8 is negative 60. 3 times 2 minus 9 times 7 is negative 57. So are the figures confirmed?
Yes.
Good. So if the figures are confirmed, that was step number 1, which is to get the minus matrix M. From there, we go to step number 2. Step number 2. So step 2 is where you get what we call cofactors matrix C. Cofactors matrix C. And the cofactors matrix C, you get it by getting this minus matrix, minus 14, minus 13, and 12, 41, 7, minus 16, 52, 11, minus 57. So what you do, ukishaikope hivyo, hii ya kwanza, the first one here, you put it, you assign it positive sign. Then you go interchanging, positive, negative, positive, negative. So this becomes minus, positive, negative, positive, negative, positive, negative, positive. So I've said you start with positive here, then you go changing whichever direction. Ukienda hivi, bora 2 signs will not follow each other. 2 signs should not follow each other. Should not follow each other. So when you have done that, when you have assigned them, you now multiply. You multiply this sign and this one and get the answer. So positive times negative, that remains as negative 14. That remains as negative 14. Wondering where to put it. Okay, so negative 14. Then this one becomes negative 41. This one remains as 52. This one becomes positive 13. This is 7. This is negative 11. This is 12. This is 60, positive 60. And this is negative 57. Negative 57. So that is what we call the cofactors matrix. That is what we call the cofactors matrix. You get it like that, the cofactors matrix. the cofactors matrix. I want to copy it here so that I have here. This is minus 14, 13, 12. Minus 41, 7, 60. 52, minus 11, minus 57. So that is our cofactors matrix C. To use this space. So step number 3. Step 3. Step 3 is called determinant. Determinant. And in getting the determinant, what we do, determinant of A, you simply take these values in row 1 of the first matrix, that is, and the values in row 1 of the cofactor matrix. You multiply as you add. So here column 1, sorry, not column, row 1 and row 1 here. But you can also take column 1 here and column 1 here, multiply, or whichever column. But for our case, what us to take these 3 multiplied by minus 14. Then you say plus 7 multiplied by minus 41. Plus 8 multiplied by 52. Should be equal to. That's how you get the determinant. So 3 times minus 14 plus 7 times minus 41 plus 8 times 52. Tell me the answer. What are you getting here when you multiply?
87.
Eh?
87.
87, good. 87. That is how you get the determinants. The next thing is to get step 4 now. Step 4 is to get what we call the adjoint matrix. The adjoint matrix, ADJ. Now the ADJ is simply the transposed cofactor. The transposed cofactor. So this one you transpose it. So that I have minus 14 here. I have minus 41. And I have 52. Then this is 13. This is 7. And minus 11. This is 12. This is 60. And this is minus 57. That's what we call the adjoint matrix. The adjoint matrix. You simply transpose the cofactor matrix. You simply transpose the cofactor matrix. And remember, we think transpose means we interchange rows and columns. And the last step, step 5, the last step, that is step number 5, it is now to get the inverse matrix. The inverse matrix. So the inverse matrix, as you can see in your notes, it is 1 out of the determinant, so 1 out of 87. You multiply by the adjoint. 1 out of 87. You multiply by the adjoint. The adjoint is negative 14, negative 41, 52. We have 13, we have 7, minus 11. We have 12, 60, and 57. So that is how you get the inverse of a 3 by 3 matrix. So for the interest of time, this one cannot allow me to do 2. So I now give you an assignment that you will try on your own. So the assignment is matrix B, which is 4, 5, 6, 7, 8, 9, 10, 11, 12. I'd like you to get inverse of that matrix. That is your assignment. Get inverse of that 3 by 3 matrix. I keep on telling you to send your answers. None of you has ever sent. And if you are not able to send the answers, you can also buy my revision kit, which will contain some of the answers. So with that, let us now look at applications of matrices. Let us proceed and look at applications of matrices. Applications of matrices. Applications of matrices. Applications of matrices. As you can see in the notes, we have several applications of matrices. One is to compute revenues, costs, and profits. We all know how to compute costs, how to compute revenues, how to compute costs. Our profits. So most of the questions we'll get, they will be about that. Number 2, how to solve simultaneous equations. Number 3 is to analyze demand and supply. Number 4 is to do something we call input-output analysis. Number 5 is something we call Markov analysis. And number 6 is something we call regression analysis. So in this one, we are going to have to start with solving simultaneous equations. And I want us to solve this question that is in your handout. It is a question of Kasneb, August 2009, question 1A. The question of August 2009, question 1A. So in your notes, hapo uandike solving simultaneous equations. That's the first application. Andika solving simultaneous equations. Should have written that. Solving simultaneous equations. That is the first application. Solving simultaneous equations. Saying you write in your notes, we are now doing solving simultaneous equations. Now the question says, Utensil Limited deals in the production of cups and bowls. The production requires machine and labor inputs as follows. So we are given that the available machine hours and labor hours are that. Use matrix algebra method to find optimal number of cups and bowls that should be produced by Utensils Limited. So when you are solving this kind of a question, The first thing is to create equations, and this is how we go about it. Let C represent the number of cups produced and sold. B represents the number of balls produced and sold. Used and sold. Then equations. Equations will be like this. Ukiangalia hapa ya kwanza, it will be 4C, that is in machine hours, plus 2B is equal to the machine hours we are told they are 100,000. That way. Then 3C plus 2B will be equal to 80,000. Will be equal to 80,000. Be equal to 80,000. When you have those equations, you express them in matrices. And when you want to express equations in terms of matrices, you take these coefficients. So we are going to have 4, 2, 3, 2. This way. You multiply by, the unknowns. C and B, yeah? C and B. They are coming to multiply this 100,000 and this 80,000. That way. Then you proceed and tell us on solving what you do, you make this to be left on its own with the subject of the formula CB that way. And then you bring this one to the other side. 4, 3, 2, 2. And because this one has changed sides, it comes in as inverse. Because it has changed sides, it comes in as inverse. To come and multiply this 100,000 and the 80,000 here, that way. Now this one is a 2 by 2 matrix. So if it's a 2 by 2 matrix, we need to get the inverse. And we know getting the inverse, we start with the determinant. So the determinant will be 4 times 2 minus 3 times 2. That is how you get the determinant. So if you take your calc, 4 times 2 minus 3 times 2 is 2. Then we need to get the new matrix. The new matrix. New matrix, tulisema, you change positions here. So this is 4, this is 2. You change signs here. This is minus 3, and this is minus 2. That way. So thus, when I proceed, I think instead of changing the camera, let me delete here. Because for you have everything. Thus, sasa nirudi hapa niseme CB is equal to, now I know the universe. The universe will be 1 out of 2 multiplied by the new matrix, which is 4 minus 3 minus 2 and 2. Now I multiply by this one, 100,000 and 80,000. That way. We know how to multiply matrices. So this proceeds to become, remember this is a 2 by 2 matrix and this is a 2 by 1. So when I start to multiply, it will be 1 out of 2. This multiplied by this, so it will be 4 times 100,000 plus this times this, minus 2 times 80,000. And then I take this one, minus 3 times 100,000 plus 2 times 80,000. So this proceeds to become 1 out of 2. When you take your calc, you say 4 times 100 plus minus 2 times 80. That is giving me 240,000. Then I say minus 3 times 100 plus 2 times 80. I should not end up with a negative. There is somewhere I've made an error. Minus 3 times this, 300. You see? My new matrix, or I did not change here, new matrix. I hope the new matrix you recorded like this. This was supposed to be 2 here. This is 4. The new matrix that we got here, it should have been 2 minus 2 minus 3 and 4. Check whether that is what we had. I have transferred the wrong figure here, or it was wrong from there, but that is how it should be. So these 4 to come here, these 2 to go here, these 3 and these 2 to change the signs. So in making that correction, then this one I will say times 2 here, so that this will be 200, get 40. Then this will be times 4 here, so that I get, this is 300, I get 20,000. get 20,000. So proceeding with my workings, I now say CB. When I open these brackets, I'm going to have 20,000 and 10,000 here. And hence, C is 20,000 and B is 10,000. And B is 10,000. That is how we solve it. Okay, let us go to the next one. The December 2011, question 1A. The December 2011, question 1A. December 2011, question 1A. It says, two traders, Anne and Terry, sell two brands of hair weaves, namely chiffon and georgette at whatever market. The table below shows the selling price in shillings of a unit of each weave. So we are given that. The total weekly sales for Anne and Terry are 1 million and 1.1 million respectively. Required. Using matrix algebra, determine the optimal combinations of the weaves that the two traders should sell. The two combinations of the weaves that the two traders should sell. So we begin again and say let C to represent number of chiffon weaves. Don't know whether that is how it's pronounced. G to represent number of georgette weaves. The number of georgette weaves sold. Then the equations. We create the equations. The equation that we create, if you look at Anne sold 300 chiffons, so 300 C. Na akauza 400 georgette, so 400 G. And she made total sales of 1 million. That is Anne. This is for Anne. When you come to Terry and use a 200 chiffons, akauza 700 georgettes, and she went home with 1.1 million. This is Madam Terry. So as I've told you, once you create the equations, you now create matrices. And matrices are created by getting these coefficients. So we have 300, 400, 200, 700. You put them that way. You say times these algebras, these are known, C and G. Coming to multiply this one, 1 million and 1.1. That way. Then on solving, I have told you what to do. Unachukua hii, the one with the notes, unaachwa on its own side, so that we have CG. That way. Then you take this one, 300, 200, 400, 700. And because it has changed position, it changes, or it comes in with inverse. It comes in with inverse that way, or an inverse. To come to multiply 1 million and 1.1. That way. Because it's a 2 by 2 matrix, and we know how to get the inverse of a 2 by 2 matrix, we start by getting the determinant. The determinant will be the major diagonal, that is 300 times 700. You minus the minor diagonal, 200 times 400. 200 times 400. So if you check from your calc, 300 times 700 minus 200 times 400, the answer is 130,000. 130,000. Then from there, you come and create the new matrix. The new matrix, we have said what you do. You interchange the major diagonal elements so that I have 700 here and I have 300 here. And the minor diagonal elements, I interchange the signs so that I have minus 200 and minus 400. That's my new matrix. And if that is my new matrix, I seek to proceed. Where I will come here and say that CG will be equal to 1 out of the determinant, 1 out of 130,000. We are multiplying by the new matrix, 700 minus 200, then minus 400 and 300, to multiply these 1 million and these 1.1. So this proceeds on to become 1 out of 130,000. You know how to multiply, so it is this multiplied by this. So I'm going to have 700 multiplied by 1 million plus minus 400 multiplied by 1.1 million. Then minus 200 multiplied by 1 million plus 300 multiplied by 1.1 million. That way. So I proceed with my workings. And at this point, I consult my calc whereby I say 700 times 1 million plus minus 400 times 1 and I'm getting 260 million. And this one will finally be, if I divide that by 130,000, it will settle, or maybe I bring it here. Here, this is coming to 2,000 when I open the brackets. Then I go to the next one, I say minus 200 multiplied by 1 million plus 300 multiplied by, I'm getting 130 million. So when I divide, that is what I'm getting. Is what I'm getting. Thus, C will be 2,000 and G will be 1,000. And G will be 1,000. So just a minute, I get a few questions in the past paper. Just a minute. Now for your assignments, like you to attempt the following. August 2022, question 1A. August 2022, question 1A. That is on addition of matrices. There should be several others. Let me get them. Yes, May 2019. May 2019. Question 1B. May 2019. Question 1B. Let me get one more. Oh, there was another one. I don't know where it is. ID. ID. Yes, I've seen it. May 2016. May 2016, question 1A. So I'd like you to attempt these three. After you attempt that, because those are 2 by 2, then you attempt this one of June 2012, and it's in the handout. June 2012, question 1A. This one is in the handout, the 3 by 3. So we stop at that point and then pick up from there tomorrow, God willing. Thank you so much.